All right. Good evening, everybody. Welcome. We've got another interesting tech talk for you tonight. This time I've checked the pronunciation of the speaker's name. This is Brae Webb. He's a PhD student at UQ, working on compiler optimizations with Ian. Brae, take it away.
Okay. Hello, I'm Brae. Welcome. Today we're going to be learning a thing or two about Bazel. Bazel is a build system. Let me just get into it. So here's what we're going to be doing today. First of all, we're going to explain a bit about what Bazel is. Then I'm going to give you an advertisement for why you might want to use it. Then we're going to try to use it, and I'm going to do a live demo for that, so forgive me and comment in the chat if you know the solution to all of my errors. And then we were going to do extending Bazel, but I don't think that's going to work, but we can try it and fail miserably. So, what is Bazel? It is pronounced Bazel. This is from Bazel's webpage, frequently asked questions. It says it's pronounced the same way as the herb, but in Australia we pronounce that Basil. In the US, for some reason, they pronounce it Bazel, so we're going to stick with Bazel. It is a build tool for multiple different languages, so you may be familiar with some build tools like Gradle and Maven and Make and Ant. Most of those were for Java, but it's generic like Make, but it has a lot of protections to ensure that you actually specify all your dependencies. It's the open source flavor of Google's internal build tool, which is called Blaze. It's an anagram of Blaze. Alright, so let me try to sell it to you very quickly. These are the list of key features that are cool about Bazel. So first of all, it is isolated, which means that it tries to keep the building of your program within its control, which just means that you have to specify all of your dependencies or it will never run for you. So it's got a very nice safety net around that. It is cached, which is very useful if you're working with a big project like Google's monorepo, which is ginormous. So yeah, Bazel's all cached, and if you change one thing, it will only rebuild what you need to rebuild rather than everything, which is very nice. And it does that using a dependency graph. So from your definitions of your build, it works out what all of the dependencies are, and it will only update the nodes of that dependency graph that it needs to. And it is also very easily extendable in a little custom subset of Python. We were going to extend it today to add new language support, but maybe not. And we'll have a look at least at how you can extend it yourself if you don't have a language that's supported. Oh, isolated, cached, dependency, extendable. Okay, so which languages does Bazel support? It supports a good chunk of languages. So if you see a language here that you're using, you can use Bazel to build it from now on. If you don't, then you get the pleasure of writing your own rules for how Bazel can build your language. Okay, so here's the fun part. What we're going to do is do a live demo of using Bazel. So the first part of that is the build file. The build file is where the Bazel magic starts. It is where so you create one for each of the packages in your repository, generally, and in your build file you specify the list of build targets using build rules. So Bazel comes with a number of built-in rules, and we're going to use some of them. So the first thing we're going to do is go into here. So we have a little tree serializer here. So this is just some Java code that allows you to take a class representation of a tree data structure and serialize it as a string that looks something like this. You don't need to know that. I don't know why I bothered explaining it, but this is just an example Java program. Okay, so all of it lives in the one file, which makes it very easy for us. So the first thing I'm going to do is to create a workspace file. So in the root of my repository, I will create a workspace file. I'm not going to explain what this is yet, we will get to it, but just know that you have to have a workspace or Bazel won't build. The second thing we want to do is we want to create a build for this program. We create a build file here, and what we can then do is use the Java binary rule. So this is one of the built-in rules of Bazel, and you have to give every rule a name. So in this case, we're going to call it tree serializer. And for the Java binary rule, it takes a sources parameter. Does it need to be, yes, build and workspace need to be capitalized. So the sources parameter takes a list of source files. So we'll just say serialized tree here. Okay, and a Java binary means that this rule is something that we can run, and if you know your Java, you know that you have to tell it what the main class is if you want to be able to run it. So we just create a rule like this. And then we will attempt to build it. So we will cd into Java tree serializer, and we have our build and our Java code. And what we can do here is just build, and we say Bazel build. So there are 3 ways to build a Bazel file. Okay, so there's 3 modes of Bazel. There's the Bazel build, which is just going to try to build and create artifacts for you. In the case of Java, that is a jar file. There is Bazel run. So if your rule is an executable rule, like Java binary is, you can use Bazel run to just run that rule. And you have Bazel test. So there are particular rules that are testable, and using Bazel test, you can integrate this into your test environment. All right, so Bazel build, that's the mode. And we give it the name of our rule, which is tree serializer. And we hope it is running, so it's going to go off and get all of the dependencies that it needs, which apparently includes some Java versions. This has not been run on this computer before. We had to do a last-minute switch, so it might take some time to go and fetch the dependencies. So be aware of that, but it worked. So what happens when you build is it'll list, oh, I can't see what I'm pointing at. It'll list all of the artifacts that it created. So here it's created a jar file because it's Java, and it's created this little executable that we could run. Since the Java binary rule is a runnable rule, we can do Bazel run, and what we get is what we expect. So if we go down to the main method here, we create a node, we serialize that node, and then we serialize and deserialize, and then serialize and print it out. That's just checking that our serializing works, and it's running as you can see. All right, so that is the very basics of Bazel. Bazel does allow you to chain these rules together. You can create all sorts of monstrosities doing that, as I have done. So moving on, so target names. As we saw here, the target name is tree serializer. And if we're in the same directory as the build file, we can just say tree serializer. What we can also do is if we're anywhere else in the repository, so let's say we're at the root of the repository here, we can do Bazel run and then 2 forward slashes to indicate from the root, and then we just give it the path, Java tree serializer, and then so we've listed the directory, and then we do a colon and we put the name of the target. Right, because the name of the base directory and the target are the same, we can leave the target name off and just run it like that if we want to. Okay, that's pretty straightforward. So, yep, what we'll do now is we'll just make this a little bit more interesting by copying over these two and so we're going to break the tree serializer, the serialized tree class out into multiple files if we can. I'm not used to this laptop, so we may not be able to. Okay. So we can copy this like that and pop it over here. So we're just going to break it out into the one separate class for now because multiple seems hard. And what we can then do is we can use Java library. So if you have some Java code that you're not expecting to run and doesn't have a main class, you can say, I want a Java library. You need to give it a name as you do with all rules, and you say the source is let's say node.java. Okay, and that one's done. And then in our Java binary, because it depends on Java library, we can say deps equals. Here what we're going to do is we need to reference the other rule, and we do that by starting with a colon, and we just say node lib here. And this now references the other rule as a dependency. And if we run tree serializer 2, tree serializer, thank you, Siri. Okay, so we've got a tree serializer that has a dependency. All right, so let's do one last basic example. So we're going to go, so I have here a very cool, very fun Mario game on the command line written in Python. And what we are going to do is see if we can create a Bazel rule to run this. So we will again say pybinary, we'll call it Mario, and we will say the sources for this is mario.py. We will also make the util file, which it imports a library. So this is a Python library. Give it a name and give it a path. And so this is a dependency of our main game. So we just reference it like this. And if we try to run that, let's see what happens. So we can say, go try to run Python Mario. And we get this error. So this is because, as I mentioned earlier, Bazel is very kind to us and it tries to isolate everything so that if we don't fully specify everything that we're depending on, it's not going to be able to run. So what we've left out here is that the Mario file tries to open this level.txt. So we actually need to tell Bazel that we are taking in level.txt and we're using that. So what it'll do is it'll copy over this level.txt into its own little isolated environment where it can then access it and we can play this fun game here. Okay? Straightforward. What we'll do now is we have in this file some tests for the Mario game. Ugh. Okay, so we've got some tests here. What we'll do is in this file we will create a PyTest rule, and we can do test Mario, and we give it the sources. So in this case it is it needs this, and it also needs as a dependency the files that it is testing. So we'll give it the Mario build target. And if we then try to run this, so in the Python Mario directory, we run test Mario rule. Okay, that runs. This is just running as a normal Python file at the moment, but if we change this mode to test, what it'll do is it'll print out this, and if you had a much bigger program, you can use Bazel's query language to run all of the tests in your repository in one go. So, yep. And so we'll talk about the Bazel querying now. So what you can do, Bazel has its own little query language. Ugh. Yep. So it's got its own little query language, and I don't remember it off by heart. So, yeah, there we go. So what we can do now is we can do Bazel query. So this is saying go find me all of the targets in this repository. That's what the 3 ellipses mean. It's a wildcard. And it would help if it was spelt right. Okay, so these are all of the targets that we could run. Okay, or build. All right, so now we've got that. What we can do is we can say, get me all of the dependencies for all of these rules. And it'll go do that for us. There we go. So this is everything that it relies on. And there is a lot there. We can be a little bit more specific and we can say, just get me all of the Python dependencies, and it'll get all of the Python dependencies. Okay, that's fairly straightforward. What we probably want to do is we want to add the no tool deps, and that'll kind of get rid of most of the unrelated dependencies. So this is just for running Bazel. We can also then, so if we want, we can say that the output format is a graph, and we can pipe that into, so if we run it like this, whoa. Yep, so if we run it like this, it gives us this dot file format. So if we pipe that into dot, which hopefully is installed, and we just do this. Oh, yes. So we can build a dependency graph of our files, and we can kind of see what's happening here. So up the top, we've got this test Mario rule, and that depends on Mario, which depends on the util rule, which depends on the util file. So we can get a nice visualization of all of our dependencies here. And generally these are going to be the complete dependencies because Bazel kind of forces it upon you. All right, so those are the main parts of Bazel. So the workspace. So remember at the start, I created a workspace. Let me just close all of these. I created a workspace file and I said, please ignore it. So every Bazel repository needs to have the workspace file at the root level. And this is where you specify all of the dependencies external to your repository. So if you need to pull in third-party dependencies, you specify them in here. So it lives in the root, specifies external. And instead of using rules, which is what we did earlier, this uses repository rules. So what we're going to do is we're going to try to build a Go program. So Go is not a built-in language that's supported. So what we'll do is hopefully not... Sorry, Nick. Okay. We'll go Google, go Bazel rules. Okay. And we get this. This is my recommended way of specifying external dependencies is you Google it, and what they will normally have in the README is one of these. So this is a little code snippet they provide to tell you how to go and specify these rules as a external dependency. So we can just copy that right in here. So what this is doing is it's importing this HTTP archive rule, which is kind of built in, and then it's saying go off and download this. So this actually contains the Go rules, and then we're importing particular repository rules from the Go rules repository. And then these, I assume, are going to go and download Go if you don't have it, and set it up in your isolated environment. Okay, so with all that in mind, all we need to do is just copy this. So in here, I have a very basic little Go program that is just basically going to print hello world. So in here, we just create a new build, and we copy, yep, and then we just say, so this is some sort of server, and its sources are main.go. So this is like an import statement here, and this is specifying go to that repository that we've installed in the workspace, and fetch this file and import the Go binary rule from that file. Okay, so now we can do Bazel build, if we like, / go, and we want to build a server target. Yeah, it's going to go do that. You can do all sorts of fun things with Bazel. You can use it for LaTeX, which is how these slides were built. You can make compositional rules if you like. So this here has gone and built our Go program, and it's put it in our bazel-bin directory. That's where Bazel stores all the executable artifacts. So we can go / bazel-bin, go server, and then _server. And that will start our server. If we go to localhost, sorry again, Nick. Okay, and it says hello world as we expected it to. If we put this here, it does that. Okay, so that's a Go program. So in this case, what we did was we went and, I don't know why I'm still pointing. We went and ran the binary executable that it created. We can also just say Bazel run, and it runs it for us, and we can see if we refresh here, it's still working. Okay, dokie. Those are the main parts of Bazel. Yep. Extending Bazel. So what I was going to do was create an example here, but I don't think it's going to work. So I'll just give you a brief overview of how you can extend Bazel if you want to. So you extend Bazel using the Starlark language, which is a subset of Python. So if you know Python, you should be very familiar with how to use Starlark to create new rules. Am I going to... Yeah, okay. So let's try and do an example. So what we're going to do is we're going to create a rule for standard ML. So standard ML is a just old functional programming language. And to do that, what we need to do is we need to go and download the standard ML compiler. There are multiple standard ML compilers. I'm going to prefer MLTON, just because. And what we will do here is we will go to SourceForge, where you can download the binaries for the compiler, and we are going to grab the link to this one, hopefully. So we're going to download this one first. Okay. So we'll get started writing them. So what I'm going to do is create a new directory, not in there, in here, called Bazel rules. And in here we can create it doesn't have to be called Bazel rules, I've just chosen to do that. We're going to create a .bazel file, which allows us to define rules here. So the first thing we want to do is give our rule a name. So we'll call it SML compiler, and we just say, so yeah, we want this to be a repository rule. So a repository rule can be used to go and fetch external dependencies, which is exactly what we want here. And we need to give it, I'm copying, an implementation. And that's what this is. And then we can just define a function with that name. Oh, sorry, I didn't see the chat. Can you specify whole directories for data? Ah, good question. So what you can do, Nick, is you can use glob. So say, for example, here, I can call the glob function, and then the lists here will use glob patterns to go find all of the Java files, or in this case, all of the Java files recursively. And we can specify however many, we can download all the things we want, run all the things we want. What do we got here? Tests do not need to be in the same directory as the source code. So what we would do, going back to, sorry, I clearly wasn't looking at the chat. Going back to here, if this was somewhere else, we would just say / another location : Mario. And that's how we can specify external dependency, non-local. Okay, all right, cool. So going back to our ML example, so rules all take in this CTX for context, and so we've got our very basic repository rule here, and hopefully, yep, so this is downloaded. Okay, and in here, yeah, so this downloads with these binaries. I don't know how much of that you can see. but we need to go and download these binaries. So what we're going to do is we're going to call ctx.download and extract. This is going to download a zip file from somewhere and extract it. We need to pass to it a URL, a SHA-256, and a strip prefix of our zip. Okay. So I'm just going to hard code this for now for Mac, but what you should really do is make it platform dependent. So for the URL, we're going to copy this link here. Will that work? Yeah, why not? So we can copy the link to this binary here, sorry, this zip archive here, and hope that works. I'm just a bit suspicious of it because it's got that /download at the end, but that's okay. We'll move on from that and hope it works. Alright, so the SHA-256, that's an excellent question of what that is, so we'll go into next downloads. Sorry. Sorry. And do we have a... No. I don't know how to hash on a Mac. MD5, no. SHA-sum. Okay, let's try that one. What is it doing? Okay, so we'll do that and we'll go hash that one. Oh, brilliant. And then we can put that in there. And the prefix, I'm going to guess, or I don't have to guess, is going to be, yeah. So this is the prefix here. So we want to get rid of that when we extract the zip file. Okay, so let's see if that worked. So what we can do is in our workspace, because this is a repository rule, we want to go and import this file. So we go Bazel rules, ml.bazel, and we will say we want the SML compiler, and we shall say go get me that, just as Go has done here. And let's see, so we can do, I think Bazel sync will try to fetch all the dependencies. Okay, so we just need to pop a build file next to this so that it can import it. You can only play around with directories that have a build in it. Yes, I did. You're too right. So I want the file there. And I've got some syntax errors. I'm glad I decided to do live demos. I'm happy with my choices. Okay. So, is it downloading? That stream is really far behind. Okay. Could not load external. So something has no name attribute. Does it need a name attribute? Yes, of course it needs a name attribute. Of course it does. Okay, back to our workspace. think it re-downloads a fresh copy every time, which is not ideal and not what we want. Okay, so we'll get started on making a regular rule. Oh, hang on. Yeah, I didn't think that would work. So we need an actual zip file rather than this SourceForge link. And I don't know how I got it before, but it's not letting me get it now. I'll see what happens if I just remove the /download at the end. Okay, that might work. So let's try that. So we'll go tell it to go download, and we'll look up download. There we go. Okay, let's give that another go, and we'll get started down here on our ML binary rule. And this also needs an implementation. And again, we want this to be a function that takes a context. And what do we want to put in here is an excellent question. So we want to output a binary file. So what we do is we call declare file. So we declare a file. We have to explicitly tell Bazel what things are going to be produced by our rule, and what we do is we say label.name. So this is going to get the name of whatever you called your rule, and just create a new file according to that. Did that work? Okay. And then we just want to, this is just boilerplate. I apologize for the boilerplate. So we just tell it that this rule is going to give us back an executable binary file that we've declared. Okay, that all looks good to me. We also want to make sure that this rule is specified as executable. And what we will do then is try to run it, I guess. Let's see what happens. So we want to go to our ML code. So this is just some ML code. If you're not familiar with it, that's okay. I'm not either. I stole this from someone. We create a new build in this directory, and we import from where we declared our ML rule. We import the ML binary rule, and we call it ML, why not? That has the nice property of when I say Bazel build ML, no I didn't, hang on. Where is it looking for that? What are you talking about? One moment, please. Oh, I see where I've screwed up. So we don't do it like that. We assign this global variable, if you like, in Python terms, to the result of calling a rule function. Okay, that's good. So this is good. This is telling us that it's going to go and create this binary file, but there's nothing telling it to create this binary file. So what we have to do is we have to do an action, and what we will do is we'll make a run action which requires an executable. Our executable, this is where things get really ugly, so apologies. Our executable is going to come from here. So we create this, and we say we want to give it the compiler, I'm not expecting people to understand this one. I'm just going to copy it verbatim from my notes here. So this is going to go and collect the binary file for MLton. And it is going to be an executable. So what I'm doing here is I'm specifying the parameters for our rule. Because I've given it a default, this isn't actually something we're going to pass in, but this is how you can configure your rule to take different parameters. Okay, so here what we then can do is we can do our context.executable._compiler, and it will fail in a different way now. Yep. Oh, this is just syntax errors. So we're missing a comma there. Okay, and we need to go here. No? Yes? Yeah, so this is basically telling us that we're trying to import from a Bazel project, but the zip file that we downloaded is not actually a Bazel project. So to make it so, in our repository rule, once we've downloaded and extracted it, we go and create a... Did I add a note for that? Yes, we go and create a new file within that zip file that we've downloaded. And we say go and export everything. So this is going to let us hopefully access everything within the downloaded zip file in some way. And if we're making a build file, we should also make a workspace file within it. And we're just going to say we're going to leave that empty. Okay, and let's see what that does. Did you update? So let's do Bazel sync. Cool. All right. So while we're doing that, the executable is not the only thing we need. We also need to give it some actions. Some arguments. And this is going to be, so we want to tell it where to output the compiled ML file. So that's going to do that. And then we want to tell it which file we want to compile. So what we'll do there is we'll allow people to give it a file. So ML, this version, it's hard to import multiple. So yeah, it's hard to import multiple files in ML with this particular compiler. So we're just going to let it only take the one file, and we'll make it mandatory, if I can spell that. Allow single file true, sure. Okay, and then what we can do here is we can do context.file.source.path and pass that in. Okay, and that is now telling us that our build here needs a source, and we say that that is regex.sml. And it's back to this error, and I'm not sure if I know how to fix this or not. So it's possible that we might leave it there. Give me 2 seconds. Yeah, I think that's as far as I'm going to get, which is much farther than I was expecting on this computer. But this is close to working. So what we have is we've created 2 new rules. So we have a repository rule that goes off and downloads the compiler binary. And then down here we have a regular rule that we can use to run that compiler binary on a specified source file. And in theory that would work. I don't know why it's not, and I'm not going to attempt to find out. Any questions? Pop them in the chat now while Nick hurries over to rush me off stage. Oh, I'm going to miss the bachelor.
Okay. Keep sending your messages through. We'll keep an eye on those. Thank you. Oh, I've got to step this way. Sorry. Big thank you to Brae. Thank you for showing us not only how Bazel works, but how to extend it.
Okay.
We look forward to having you back a couple of times over the course of your PhD. Awesome. Thank you all for coming. Again, keep an eye out next week. We have Damien Brady coming to talk about DevOps, and we have the committee's own James Copperthwaite to talk about finance for computer science. We'll also have CPG running again next week. I'll keep you updated on the topic that they'll be going over. Alrighty, thank you.
Are we free?
Yep.
Okay, good. I made the mistake last talk to